something is moving toward Earth, and it's bigger than anyone expected.
Satellite images just confirmed. Comet R2 Swan has shifted course straight toward Earth.
Experts are warning, if this trajectory holds, impact could happen much sooner than anyone expected.
NASA's emergency briefing has been delayed again, fueling speculation they're hiding something massive.
Whatever this is, it's not just another space rock. It's unlike anything we've never seen before.
Telescopes across the world have begun to pick it up, just a faint reflection at first, but growing day by day. What is it? Where did it come from? And why are some experts warning that it could change everything we know about the universe and possibly our future on Earth? It began quietly. On a cold, clear night in Chile's Atacama Desert, the European Southern Observatory logged a strange anomaly, an unusually bright reflection moving in a trajectory that didn't match any known comet or asteroid. At first, it was dismissed as a fragment, perhaps space debris or a rogue satellite. But within hours, it became clear this was something else entirely. Its orbit wasn't just off, it was impossible. Unlike typical comets that move in predictable elliptical paths around the sun, this object was moving too fast, slicing through the solar system. Early readings suggested it wasn't gravitationally bound to the sun at all. It was passing through. That made it interstellar, just like 3I Atlas, the bizarre, cigar-shaped visitor that baffled astronomers years earlier. When the data was shared with NASA's Jet Propulsion Laboratory, analysts immediately noticed its infrared signature. It was faintly glowing as if heated from within. Not ice. What kind of object burns cold, but shines bright in deep space? As reports poured in from observatories in Hawaii, Australia, and Japan, a name was assigned. R2 Swan, a temporary designation marking it as a comet candidate. But candidate was the key word, because what researchers found didn't behave like a comet at all. Most comets form a visible coma, that glowing halo of ice and dust burned off by solar radiation. Yet R2 Swan's light remained steady, not flaring or fading. It emitted faint, rhythmic pulses, almost like a heartbeat. Radio telescopes picked up subtle frequency modulations in the reflection, patterns that some described as unnatural. NASA and ESA publicly labeled it a high-interest object, but quietly, communication blackouts began. Several observatory data feeds suddenly went offline. When data from the Hubble Space Telescope was requested, access was denied. Even amateur astronomers noticed it. The coordinates for R2 Swan vanished from online tracking systems overnight. Why would they hide its location, unless there's something to hide? To understand why scientists are so alarmed, we need to revisit 3I Atlas, the third interstellar object ever discovered. When it entered our system, it was unlike anything humanity had seen before. A fast-moving body that defied gravitational predictions, almost changing direction mid-flight. Some believed it was just an icy fragment from another star system, but others, including Harvard astrophysicist Avi Loeb, argued it might be an artificial probe sent intentionally. It reflected light too efficiently for a natural rock and accelerated as if powered by something unseen. Comparisons reveal a disturbing pattern. Both 3I Atlas and R2 Swan share identical inclination angles, entering our solar system from near the same galactic plane. But this time, it's coming closer. Its projected path intersects directly with Earth's orbital line by next month. The odds of that alignment happening naturally, astronomically small. Scientists at CERN and the European Space Agency recently detected faint energy spikes coinciding with R2 Swan's appearance. The readings match no known cosmic background activity. Instead, they resemble low-frequency radiation bursts, short, symmetrical pulses emanating directly from the object's coordinates. Some theorists speculate it could be a form of communication or propulsion. But here's the twist: these pulses have patterns. The intervals between them form mathematical ratios found in hydrogen spectral lines, the fundamental frequency of the universe itself. The energy output, while small, has been growing. Every 72 hours, the pulse amplitude increases. Could R2 Swan be powering up? Or is it reacting to our sun's gravitational field, waking somehow as it nears our star? No one at NASA will say, but leaked memos suggest scientists are recalculating its mass. And if the numbers are right, it's 5 times larger than 3I Atlas. Something strange happened last week. The Minor Planet Center, the database responsible for logging all near-Earth objects, quietly removed several recent entries. Among them R2 Swan. In its place appeared a single note: data under review. Moments later, major astronomy discussion boards lit up with questions. Within hours, moderators deleted them. Threads vanished. Accounts were suspended. In 2017, when 1I/Oumuamua passed by, space agencies held daily briefings. When 2I/Borisov entered, NASA celebrated the discovery. But now, as something larger and more mysterious approaches, the silence is deafening. Why? Could they fear public panic? Or perhaps they're not sure what it is, and that uncertainty is more dangerous than the object itself. Astronomers use spectroscopy to determine what objects are made of by analyzing the light they reflect. But when the Keck Observatory tried this on R2 Swan, the results made no sense. The spectrum contained elements unknown to the periodic table, sharp emission lines that didn't correspond to any natural material. Some lines matched theoretical elements predicted to exist only in supernova cores, materials that shouldn't survive in open space. One hypothesis is that it's covered in a reflective shell of exotic metals, possibly superconductive at cosmic temperatures. Another theory, proposed by a retired NASA engineer, suggests R2 Swan may not be solid at all, but a structure, hollow and engineered, designed to harvest solar energy as it passes through star systems. If true, then it's not a comet, it's a craft. Orbital data now predicts a close approach by the middle of next month, within 0.11 astronomical units, closer than Mercury's orbit. That's enough for Earth-based telescopes to capture high-resolution imagery. But whether those images will ever be made public is another story. Some leaked radar data from an ESA tracking station in Spain suggests the object has changed trajectory slightly, almost as if it adjusted course. That shift, if deliberate, would be the most shocking evidence of all proof of intelligent control. Over the past 2 weeks, R2 Swan's velocity has decreased by nearly 8%. That cannot happen to a natural interstellar object unless acted upon by force or by choice. Is it preparing for something? NASA's Solar and Heliospheric Observatory recorded a curious phenomenon as R2 Swan approached the heliosphere. A dark wave, a shadow across the solar wind. For several hours, sensors across multiple satellites detected a localized magnetic fluctuation, like a void moving through the energy field around the sun. Scientists call it a negative density pocket. It's as though the object bends not just light, but energy itself, absorbing solar wind instead of reflecting it. Some experts fear that if it comes too close to Earth, it could briefly disrupt our magnetic field, affecting satellites, navigation, even power grids. But others whisper a darker theory: it's studying us. In ancient Babylonian star maps, there are references to a blue wanderer that appeared once every age, followed by great storms and lights in the sky. Chinese astronomers recorded a similar event around 240 BC, describing an object that did not burn nor fade as it crossed the heavens. What if humanity has seen this before and simply forgotten? Could these interstellar visitors follow a predictable cycle, returning every few millennia? If so, what happened the last time it passed by? Right now, R2 Swan is closing in. Its light grows stronger every night, a steady pulse against the darkness. Amateur astronomers in South America have started reporting an odd hum, faint radio interference that peaks when they aim their antennas toward its coordinates. What happens when it arrives? NASA's predictive models show a near miss, a safe pass. But leaked data suggests a 1 in 7 chance of gravitational interaction, enough to alter Earth's upper atmosphere, or worse, redirect fragments toward us. If it truly is artificial, that encounter might not be a coincidence. For now, the agency stays silent, but as next month approaches, all eyes turn skyward. Will R2 Swan simply pass us by, or is it coming for us? And maybe that's the most haunting part of all: the silence. No alarms, no breaking news, just a quiet, deliberate calm as something enormous glides closer to our fragile world. We've always believed we would see it coming, that if something truly world-changing were out there, we'd be told. But history shows that the biggest revelations don't come with warning sirens. They arrive like whispers from the dark, wrapped in mystery, hidden behind coded data and vanishing observatory feeds. So as the days tick down and R2 Swan approaches its closest pass, one question remains: what if this is not just another interstellar visitor, but a message? A sign that something beyond human understanding is watching, waiting, measuring us. Because if this object is anything like 3I Atlas, or something even greater, then perhaps it's not coming for Earth by accident. Perhaps it's coming because of us. Maybe, just maybe, R2 Swan isn't the first. What if dozens of these interstellar travelers have passed before, unseen, silent, hidden by time and distance, watching civilizations rise and fall, waiting for one moment in history when we'd finally notice? Could this be the moment they've been waiting for, when humanity looks back into the dark and realizes it's not alone? Every data feed, every missing signal, every vanishing update could be part of something much larger, something orchestrated. And as the object drifts closer, there's one final truth we can't escape. If this really is a message, then it's already been sent. Whether we respond or not may define our place in the universe. Because sometimes, the most terrifying discovery isn't that something is coming for Earth. It's that it's already here, watching, listening, and waiting for us to finally understand. In the coming days, the world's most advanced telescopes will turn their gaze toward the coordinates of R2 Swan. But as the light from that distant traveler reaches our lenses, we may not be ready for what it reveals. Whether it's rock, metal, or something engineered, one fact remains: it is moving with purpose. And if it truly has altered its course, if it has chosen this path, then every calculation, every prediction, every assumption about our cosmic isolation collapses overnight. So as the countdown continues and the sky begins to shift, remember this: history is written by those who dare to look up. Maybe the reason the agencies stay silent isn't because they're hiding the truth, but because they don't understand it either. And when the first clear image of R2 Swan finally appears, it might not just change what we see in the heavens, it might change what we believe about ourselves.